Welcome to Data Analytics using Python. My name is Richard Kirschner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. So we're going to cover data analytics with Python. We're going to go over what is data analytics, applications of data analytics, types of data analytics process steps, why Python for data analytics, and then we'll dive into use case demo so you can actually see some script and actually see what it looks like in the Python code. What is data analytics? Data analytics is a process of exploring and analyzing large data sets to make predictions and help data-driven decision making. Now, the definition of large data sets keeps changing, and so this can range really from just about anything to anything. But usually in today's world, we're talking significantly larger amounts of data that you can't just glance at and try to figure it out yourself. And the two steps are analyze the data and then make decisions based on the data. Applications of data analytics. Now, the sky's the limit on this. In today's world, almost every business, act of life, your music on your Spotify are driven by data analytics. But some of the big players, when you go in there job hunting, are going to be your fraud analysis. If you want to go make a lot of money and you're good at it and you like dealing with numbers, go join the banks and track down the criminals who are stealing money. It's a lot of, it's a big thing to protect credit cards, protect sales purchases, bad checks, any of those things. When you can track them down is huge. Healthcare, exploding. There's everything from trying to find cures for the COVID virus or any of the viruses out there, using your cell phone to diagnose different ailments. That way you don't have to go in and see the doctor. You can actually just go in there and take a picture of the funky growth on your arm. Hopefully it's not too big. And then they send it in there and the data analytics goes in there and looks at it and says, oh, this is what this is. This is a professional you need to go see or don't need to see. And that's just one aspect of healthcare. The databases being generated by healthcare and getting the right doctors and helping the doctors analyze whether something is benign or malignant, if it's cancerous. All those things are now part of the ongoing healthcare growth in data analytics. Inventory management. Think one of those huge warehouses where they're shipping out all the goods. How do you inventory that in such a way so that you maximize the stuff that's being purchased the most near the entrance and all the other stuff towards the back, or even pre-ship it? So it's huge to be able to manage your inventory, and pretty soon they'll just have a drone come in there and start picking up some of those boxes and move them around also. Delivery logistics. Again, this goes from getting from point A to point B. You can combine it with our inventory, so you pre-ship stuff if you know a certain area is more likely to purchase it. How do you get the delivery to the most destinations the quickest in the short amount of time? And then they even pre-stack the trucks going out, and that's all done with data analytics. How do we stack all that stuff so it comes out in the right order? Targeted marketing, huge industry. Any kind of marketing, whether you're generating the right content for the marketing, who are you targeting with that marketing, researching the people, what they want, so you know what products to market out there, all those things are huge. And these are just a few examples. You can probably go way beyond this, from tracking forest fires to astrology and studying the stars. All of this is part of data analytics now and plays a huge role in all these different areas. City planning is another one. You can see a nice organized city like this one where you can get in and out of the neighborhoods if you're a fire truck. Police officers need to be able to get in and out. You want your tourists to be able to come in, yet you still want the place to look nice, and you have the right commercial development, the right industrial development, like enough residents for people to stay. All those things are part of your city planning. Again, huge in data analytics. So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many sales per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up and the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive, and then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. If we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse cells, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three, because a lot of people stumble on this when they come in and are doing analytics. Whether you're the manager, shareholder, or the data scientist coming in, you really need to understand the descriptive analytics, where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future, gear up for how many employees we need, how much money we're going to make, and prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture. We're going to guess at what the area is looking for and how that marketing is going to change. Data analytics process steps. So let's take a look at some of the basic processing and what that looks like when you're working with this data. So there's 5 basic steps. The 5 steps of processing, and this changes, and then there's a lot of things that go on when they talk about agile programming. The whole concept of agile is you take some kind of framework like this and then you build on it depending on what your business needs. So the first step is data collection. And usually with a large company you might have somebody who is responsible for the database management. You might have another one where they're pulling APIs and they're pulling data off of maybe the Census Bureau, maybe something very, very specific, domain specific. So if you're analyzing cancerous growths and how to understand them, then the data collection is going to be those measurements they take from the MRI. Or it might be even the MRI images. They've used those also. So there's a lot of things with data collection and how to control that and make sure it has what you need and is clean and you don't have misinformation coming in. Once you have the data collected, there's a data preparation. So stage 2 is we take that data and we format it into something we can use. Probably one of the biggest formats that you see is when you're processing text. How do you process text? Well, you use what they call a one-hot encoder, and each word is represented by a yes-no kind of setup. So it'd be like a long array of bits. That's one way to prepare it. And so, bit number 1 is the. Bit number 2 is has, or whatever it is. Other preparations might be if you're using neural networks, you might be taking integers or float numbers and converting them to a value between 0 and 1. That way you don't have one of them creating a bias in there. So there's a lot of different things that go into data preparation. That is 80% of data science. So when we talk about the data analytics, which is a little bit more on the math side, and they usually talk about a data scientist kind of being the overall preparer of this stuff, you're going to spend 80% of your data preparation. Data exploration, that's the fun part. This is where you're exploring things. And it is maybe 10 to 15% of what you do with the data you spend with the data exploration. It is probably the most important step, because this is where you got to start asking questions. If you ask your questions wrong, you're going to get some wrong information. If you're working with a company and they want to know the marketing values, then you really got to focus on, hey, how do we generate money for this company? Or fraud, how do we lower the fraud rate while still generating a profit? 4, data modeling. This is where we start actually getting into the data code, which model to use that predicts what's going to happen. And then result interpretation. We want to be able to interpret those results. You usually see that in your Matplotlib library, where you create nice, beautiful images so that it shows up on their dashboard for the marketing manager or for the CEO, so they can take a quick look and say, hey, I can see what's going on there. You want to reduce it to something they can easily read. They don't want to hear the scientific terms. They want to see something they can use. And we'll talk about that a little bit more when we start looking at some of this in a demo. Since this is data analysis with Python, we got to ask the question, why Python for data analytics? I mean, there's C++, there's Java, there's .NET from Microsoft. Why do people go to Python for it? So the number of reasons. 1, it's easy to learn with simple syntax. You don't have a very high typeset like you do in Java and other coding, so it allows you to kind of be a little lazy in your programming. That doesn't mean that it can't be set that way and that you don't have to be careful. It just means you can spin up a code much quicker in Python. The same amount of code to do something in Python a lot of times is 1, 2, or 3 or 4 lines, where when I did the same thing, say in Java, I found myself with 10, 12, 13, 20 lines, depending on what it was. It's very scalable and flexible. So there's our flexibility, because you can do a lot with it, and you can easily scale it up. You can go from something on your machine to using PySpark into the Spark environment and spread that across hundreds, if not thousands of servers across terabytes of data or petabytes of data. So it's very scalable. There's a huge collection of libraries. This one's always interesting because Java has a huge collection of libraries. C has a huge collection of libraries. .NET does, and they're always in competition to get those libraries out. Scala for your Spark. All those have huge collections of libraries. This is always changing, but because Python's open source, you almost always have easy to access libraries that anybody can use. You don't have to go check your licensing and have special licensing like you do in some packages. Graphics and visualization, they have a really powerful package for that, so it makes it easy to create nice displays for people to read. And community support. Because Python is open source, it has a huge community that supports it. You can do a quick Google and probably find a solution for almost anything you're working on. Python libraries. Let's bring it together. We have data analytics and we have Python. So when we're talking data analytics, we're talking Python libraries for data analytics. And the big 5 players are NumPy, Pandas, Matplotlib, SciPy, which is going to be in the background, so we're not going to talk too much about the scientific formulas in SciPy, and scikit. So NumPy supports n-dimensional arrays, provides numerical computing tools useful for linear algebra and Fourier transform. And you can think of this as just a grid of numbers. And you can even have a grid inside a grid, or data. It's not even numbers, because you can also put words and characters and just about anything into that array. But you can think of a grid, and then you can have a grid inside a grid, and you end up with a nice 3-dimensional array. If you want to talk 3-dimensional array, you can think of images. You have your 3 channels of color, 4 if you have an alpha, and then you have your XY coordinates for the image we're looking at. So you can go X, Y, and then what are the 3 channels to generate that color. And NumPy isn't restricted to 3 dimensions. You could imagine watching a movie. Well, now you have your movie clips, and they each have their X number of frames, and each of those frames have X number of XY coordinates for the pictures in each frame, and then you have your 3 dimensions for the colors. So NumPy is just a great way to work with n-dimensional arrays. Now closely with NumPy is Pandas. Useful for handling missing data, perform mathematical operations, provides functions to manipulate data. Pandas is becoming huge because it is basically a data frame. And if you're working with big data and you're working in Spark or any of the other major packages out there, you realize that the data frame is very central to a lot of that. And you can look at it as a Excel spreadsheet. You have your columns, you have your rows or indexes, and you can do all kinds of different manipulations of the data within. including filling in missing data, which is a big thing when you're dealing with large pools or lakes of data where they might be collected differently from different locations. And Matplotlib. We did kick over the SciPy, which is a lot of mathematical computations, which usually runs in the background of NumPy and Pandas. Although you do use them, they're useful for a lot of other things in there. But the Matplotlib, that's the final part. That's what you want to show people. And this is your plotting library in Python. Several toolkits extend Matplotlib functionality. There's like 100 different toolkits to extend Matplotlib, which range from how to properly display star constellations from astronomy. There's a very specific one built just for that, all the way to some very generic ones. We'll actually add Seaborn in when we do the labs in a minute. Several toolkits extend Matplotlib functionality, and it creates interactive visualization. So there's all kinds of cool things you can do as far as just displaying graphs, and there's even some that you can create interactive graphs. We won't do the interactive graphs, but you'll see, you'll get a pretty good grasp of some of the different things you can do in Matplotlib. Let's jump over to the demo, which is my favorite. Roll up our sleeves, get our hands in on what we're doing. Now, there's a lot of options when we're dealing with Python. You can use PyCharm as a really popular one. And you'll see this all over the place. So it's one of the main ones that's out there, and there's a lot of other ones. I used to use NetBeans, which has kind of lost favor. Don't even have it installed on my new computer. But the most popular one right now for data science. Now, PyCharm is really popular for Python general development. For data science, we usually go to Jupyter Notebook or Anaconda. And we're going to jump into Anaconda because that's my favorite one to go to because it has a lot of external tools for us. We're not going to dig into those, but we will pop in there so you can see what it looks like. So with Anaconda, we have our Jupyter Lab, we have our notebook. These are identical. Jupyter Lab is an upgrade to the notebooks with multiple tabs. That's all it is. And we'll be using the notebook. And you can see that PyCharm is so popular with Python that we even have it highlighted here in Anaconda as part of the setup. Jupyter Notebook can also be a standalone. So we're actually going to be running Jupyter Notebook. And then you have your different environments. We're going to be under main Py36. There's a root one. And I usually label it Py36. The reason is currently as of writing this, TensorFlow only works in 3.6 and not in 3.7 or 3.8 for doing neural networks. But you can actually have multiple environments, which is nice. They separate the kernels, so it helps protect your computer when you're doing development. And this is just a great way to do a display or a demo, especially if you're looking for that job. Pull up your laptop, open it up. Or if you're doing a meeting, get it broadcast up to the big screen so that the CEO can see what you're looking at. And when we launch the notebook, it actually opens up a file browser in whatever web browser you have. This happens to be Chrome. And then you can just go under New. There's a lot of different options depending on what you have installed. Python 3. And this just creates an untitled version of this. And you can see here I'm actually in a Simplilearn folder for other work I've done for Simplilearn. And that's where I save all my stuff and I can browse through other folders, making it real easy to jump from one project to another. And under here, we'll go ahead and change the name of this, and we'll go ahead and rename it Data Analytics. Data Analytics. Just so I can remember what I was doing. Which is probably about 50 of the folders in here, or files in here right now. So let's go ahead and jump in there and take a look at some of these different tools that we were looking at. And as we go through the demo, let's start with the NumPy. The least visually exciting. And I'm going to zoom in here so you can see what we're doing. And the first thing we want to do is import NumPy. And we'll import it as NP. That is the most common NumPy terminology. And let's go ahead and change the view so we also have the line numbers. I don't know why, we probably won't need them, but I like it for easy reference. And then we'll create a one-dimensional array. We'll just call this array1. And it equals np.array, and you put your array information in here. In this case, we'll spell it out. You can actually do like a range and other ways. There's lots of ways to generate these arrays. But we'll just do 1, 2, 3, so 3 integers. And if we print our array1, we can go ahead and run this. And you can see right here it prints 1, 2, 3. You can see why this is a really nice interface to show other people what you're doing with the Jupyter Notebook. So this is the basic. We've created an array. This is a one-dimensional array, and then the array is 1, 2, 3. One of the nice things about the Jupyter Notebook is whatever ran in this first setup is still running, is still in the kernel. So it still has the NumPy imported as NP, and it still has our variable ARR1 for array 1 equal to NP array of 1, 2, 3. So when we go to the next cell, we can check the type of the array. We're just going to print. We say, hey, what is this setup in here? And we want type, and then we want, what is the type of array 1? And let's go ahead and run that. And it says class NumPy ND array. So it's its own class. That's all we're doing is checking to see what that class is. And if you're going to look at the array class, probably the biggest thing you do, I don't know how many times I find myself doing this. Because I forget what I'm working on, and I forget I'm working with a 3-dimensional or 4-dimensional array. And I have to reformat somehow so it works with whatever other things I have. And so we do the array shape. The array shape is just 3 because it has 3 members and it's a 1-dimensional array. That's all that is. And with the NumPy array, we can easily access, stick with the print statement. If you actually put a variable in Jupyter Notebook and it's the last one in the cell, it will be the same as a print statement. So if I do this, where array 1 of 2, it's the same as doing print array of 2. Those are identical statements in our Jupyter Notebook. We'll go and stick with the print on this one. And it's 3. So there's our print space 2, and we have 0, 1, 2, 2 equals 3. We can easily change that. So we have array 1 of place 2 equals 5. And then if we print our array 1, you can see right down here when it comes out, it's 1, 2, and 5. And there I left the print statement off because it's the last variable in the list. It'll always print the variable if you just put it in like that. That's a Jupyter Notebook thing. Don't do that in PyCharm. I've forgotten before doing a demo. And we talked about multiple dimensions, so we'll do an array, 2-dimensional array. And this is again a NumPy array. And in the NumPy array, we need our first dimension, we'll do 1, 2, 3. And our second dimension, 3, 4, 5. And you can see right here that when we hit the, we'll do this, we'll just do array 2. And we can run that, and there's our array 2, 1, 2, 3, 3, 4, 5. We can also do array 2 of 1. And then we can do, let's do 0. Doesn't really matter which one. Actually, let's do 2. There we go. And if I run this, it'll print out 5. Because here we are. This is 0. 0, 1, 2, 3 is on our 0 row. 3, 4, 5 is on our 1 row. I always start with 0. And then the 2, 0, 1, 2 goes to the 5. And then maybe we forgot what we were working with. So we'll go do array2.shape. And if we do array2 of shape, we'll go and run that. We'll see we have 2 rows, and each row has 3 elements. 2-dimensional array, 2, 3. If you looked up here when we did it before, it just had 3, nothing. When you have a single entity, it always saves it as a tuple with a blank space. But you can see right here we have 2, 3. And if you remember from up here, we just did this array 2 of, let's go, what is it, 1, 2. We run that, we get the 5. You can also count backwards. This is kind of fun. And you'll see I just kind of switched something on you because you can also do 1, 2 to get to the same spot. Now 2 is the last one, 0, 1, 2. It's the last one in there. We can count backwards and do -1. And if we run this, we get the same answer. Whether we count it as, let's go back up here. Whether we count this as 0, 1, 2, or we count backwards as -1, -2, -3. And you can see that if I change this -1 to a -2 and run that, I get 4, which is going backwards, -1, -2. So there's a lot of different ways to reference what we're working on inside the NumPy array. It's really a cool tool. It's got a lot of things you can do with it. And we talked about the fact that it can also hold things that are not values, and we'll call this array ask for strings equals np.array. Put our setup in there, brackets, and let's go China, India, USA, Mexico. It doesn't matter, we can make whatever we want on here. And if we print that out, we run this, you can see that we get our NumPy array, China, India, USA, Mexico. It even gives us our D type of a U6. And a lot of times when you're messing with data, we'll call this array R for range, just to kind of keep it uniform. np.arange. So this is a command inside NumPy to create a range of numbers. And if you're testing data, maybe you want, maybe you have equal time increments that are spaced a certain point apart. But in this case, we're just going to do integers. And we're going to do a setup from 0 to 20, skipping every other one. And we'll print it out and see what that looks like. And you can see here we have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Like you expected, it skips every one. And just a quick note, there's no 20 on here. Why? Well, this starts at 0 and counts up to 20. So if you're used to another language where it explicitly says less than or less than equal to 20, like for x equals 0, x plus plus, x is less than 20. That's what this is. It just assumes x is less than 20 on here. And if we want to create a very uniform set, 0, 2, 4, 6, what happens if I want to create numbers from 0 to 10, but I need 20 increments in there? We can do that with line space. So we can create an R, we'll call this L, equals, I don't think we'll actually use any of this again, so I don't know why I'm creating unique identifiers for it. But we'll do NP, lin space, and we're going to do 0 to 10, or 0 to 9. Remember, it goes up to 10. And then we want to, let's say we have 20 different increments in there. So we're creating we have a data set, and we know it's over a certain time period, and we need to divide that time period by 20. And it happens to just have 10 pieces in it. And here we go. You can see right here, we have 20, or it has 20 pieces in it, but it's over 10 years. And we got to divide it in the middle. And you can see it goes 0.52. Remember, yeah, there's our 10 on the end, so it goes up to 10. And then we can also do random. There's np.random. If you're doing neural networks, usually you start it by seeding it with random numbers. And we'll just do np.random, and we'll just call this array. We'll stop giving it unique numbers. We'll print that one out and run it. And you can see we have random numbers. They are 0 to 1. So you'll see that all these numbers are under 1. And you can easily alter that by multiplying them out or something like that if you want to do like 0 to 100. You can also round them up if it's integer 0 to 100. There's all kinds of things you can do, but it generates a random float between 0 and 1. And you have a couple options. You could reshape that, or you can just generate them in whatever shape you want. And so we can see here, we did 3 and 4, and so you can see 3 rows by 4 variables. Same thing as doing a reshape of 12 variables to 3 and 4. And if you're going to do that, you might need an empty data set. I have had this come up many times where I need to start off with 0, and I don't know, because I'm going to be adding stuff in there, or it might be 0 and 1, where 1 is, if you're removing the background of an image, you might want the background is 0, and then you figure out where the image is, and you set all those boxes to 1, and you create a mask. So creating masks over images is really big, and doing that with a NumPy array of 0. And we can also give it a space. And we'll just do this all in one shot this time. And we'll do the same thing like we did before, zeros, and in this case we'll do 2, 3. And so when we run this, forgot the asterisks around it. I knew I was forgetting something. There we go. So when we run this, you can see here we have our 10 zeros in a row, and maybe this is a mask for an image, and so it has 2 rows of 3 digits in it. So it's a very small image, little tiny pixel. And maybe you're looking to do something the opposite way. Instead of creating a mask of zeros and filling in with ones, maybe you want to create a mask of ones and fill them in with zeros. And we'll just do, just like we did before, we'll do 3, 4. And when we run this, you'll see it's all ones. And we could even do this even, we'll do it this way. Let's do 10 by 10 icon, and then you have your 3 colors. And you can, so it creates quite a large array there for doing pictures and stuff like that when you add that 3rd dimension in. If we take that off, it's a little bit easier to see. We'll do 10 again. And you can easily see how we have 10 rows of 10 ones. And you can also do something like create an array. And we'll do 0, 1, 2. And then in this array, we actually, we'll print it right out. We want a repeat. And so you can actually do a repeat of the array, and maybe you need this array, let's repeat it 3 times. So there's our repeat of an array, repeat 3 times. And if we run this, you'll see we have 0, 0, 0, 1, 1, 1, 2, 2, 2. And whenever I think of a repeat, I don't really think of repeating being the first digit 3 times, the second digit. I really always think of it as 0, 1, 2, 0, 1, 2, 0, 1, 2. It catches me every time. But the actual code for that one is going to be tile. And again, if we do arrange 3 and we run this, you can see how you can generate 0, 1, 2, 0, 1, 2, 0, 1, 2. And if you're dealing with an identity matrix, we can do that also if you're big on doing your matrices. And we'll just identity. I guess we'll go ahead and spell it out today. Matrix. And the command we're looking for is EYE. And we'll do 3. And then we'll just go ahead and print this out. There we go. There's our identity matrix. And it comes out by a 3 by 3 array, because there's our matrix. And then it puts the ones down the middle and for doing your different matrix math. And we can manipulate that a little bit too. We talk about matrices. We might not want ones across the middle, in which case we now have the diagonal. So we can do an np.diagonal. And we do a diagonal. Let's put in the diagonal 1, 2, 3, 4, 5. And when we run this, again, this generates a value. And by just putting that value in, there's the same as putting print around it, or putting array equals and then print array. And you can see it generates a diagonal 1, 2, 3, 4, 5, and there's your beginning of your matrix array for working with matrices. And we can actually go in reverse. Let's create an array equals, remember our random dot-random, and we'll do a 5 by 5 array. Oops, there we go. 5 by 5. And just so you can see what that looks like. Helps if I don't mistype the numbers, which in this case I just need to take out the brackets. And there you go. You have your 5 by 5 array set up in there. And we can now, because we're working with matrices, we might want to do this in reverse and extract the diagonals, which would be the 0.79, the 0.678, and so on. And we simply type in np.diagonal. And we put our array in there. And this will, of course, print it out because it returns it as a variable. And you can see here, here's our diagonal going across from our matrix. And we did talk about shape earlier. If you remember, you can do print the shape out. You can also do the dimensions. So in dimensions, very similar to shape, it comes out and just has 2 dimensions. We can also look at the size. So if we do size on here, we can run that, and you can see it has a size of 25, 2 dimensions, and of course 5 by 5. And that was from the shape from earlier that we looked at. There's our 5 by 5 shape. And if you remember earlier we did random, well, you can also do random. I talked a little bit about manipulating 0 to 1 and how you can get different answers. You can also do straight for the integer part, and we'll do minus 10 to 10, 4. And so we're going to generate random integers between minus 10 to 10. We're going to generate 4 of those. And so when we run that, we have 7, minus 3, minus 6, minus 3. They're all between minus 10 and 10, and there's 4 of them. And now we jump into some of the functionality of arrays, which is really great, because this is where they come in. Here's the array, and you can add 10 to it. And if I run this, there it takes my original array from up here with the integers and adds 10 to all of those values. So now we have, oh, this is the decimal, that's right. This is a random decimal I had stored in an array. But this takes the random numbers I had from 0 to 1 and adds 10 to them. And we can just as easily do minus 10. We could even do times 2. And we could do divide by 2. And it'll take that random number we generated and cut it in half. So now all these numbers are under 0.5. Another way you can change the numbers to what you need on there. And as you dig deeper into NumPy, we can also do exponential. So as an exponential function, which would generate some interesting numbers off of the random. So we're taking them to the power, I don't even remember what the original numbers in the array were, because we did the random numbers up there. Here's our original numbers, and if you build an exponential on there, this is where you get e to the x on this. And just like you can do e to the x, you can also do the log. So if you're doing logarithmic functions, that reinforced learning, you might be doing some kind of log setup on there, and you can see the logarithmic of these different array numbers. And if you're working with log base 2, you can just change it in there, np log 2. You have to look it up, because this is not log 1, 2, 3, 4, 5. It is log and log 2. So just a quick note, that's not a variable going in. That is an actual command. There's a number of them in there, and you'll have to go look and see what the documentation is. But you can also do log 10. So here's log value 10. Some other really cool functions you can do with this is your sine. So we can take a sine value of all of our different values in there. And if you have sine, you of course have cosine. We can run that. So here's the cosine of those. And if you're doing activations in your NumPy array and you're doing a tangent activation, there's your tangent for that. And the tangent activation is actually from neural networks. That's one of the ways you can activate it, because it forms a nice curve between from whether you're generating 1 to -1 with some discrepancy in the middle. Just jumping a little bit in there into neural networks. And then we get into, let me just put the array back out there so that we can see it while we're doing this. As we're getting into this, you can also sum the values. So we have np sum, and you can do a summation of all the values in this array. And you'll see that if you added all these together, they'd equal 12.519, and so on. I don't know what the whole setup is in there. But you can see right here the summation of this. One of the things you can also do is by axes. So we could do axes equals 0. And if we run the summation of the axes equals 0, and you can think of that in NumPy as the rows. So that would be, or you can think of that in NumPy as being the columns. We're summing these columns going across. And you can also change this to 1, and now we're summing the rows. And so that is the summation of this row, and so forth going down. And maybe you don't need to know the summation. Maybe what you're looking for is the minimum. So here's our minimal. You're looking for, and this comes up a lot because you have like your errors. We want to find the minimal error inside of this array. And just like the other one, we can do axes equals 0. And you can see here 0.0645 is the smallest number in this first column is 0.0645 and so on. And if you have a minimum, well, you might also want to know the max. Maybe we're looking for the maximum profit. And here we go. You can see maximum 0.79 is the maximum on this first column. And just like we did before, you can change this to a 1 on axes. You can take the axes out of here and just find the max value for the whole array. And the max value in here was 0.8344, so on and so on. And since we're talking data analytics, we want to go ahead and look at the mean. Pretty much the same as the average. This is the mean across the whole thing. And just like we did before, we could also do axes equals 0. And then you'll see this is the mean of this axis and so on. And we have mean. We might want to know the median. And there's our median, our most common numbers. If we have median, we might want to know the standard deviation. Or if we have the average, a lot of times you do the means and the standard deviation. We can run that, and there's our standard deviations along the axes. We can also do it across the whole array. If we're going to do standard deviations, there's also variance, which is your VAR. And there's our variance across the different levels. And so if we looked at that, we looked at variance, we looked at standard deviation, the median, and the means. There's more, but those are the most common ones used with data analytics. And then going through your data and figuring out what you're going to present to the shareholders. And some other things we can do is we can actually take slices. You'll hear that terminology. And a slice might be, like we have a 5 by 5 array, but maybe we don't want the whole array. Maybe we want from 1 on, we don't want the 0 in there. So we got up to 4. And maybe on the second part, we just want 2 to row 3. And so this notation right here says 1 to the end. And if we run this, you can see how that generates a single row to the end, and then row 2 and 3. Now remember, it doesn't include 3. That's why we only get the 1 column. So if you wanted 2 and 3, you would need to go ahead and go 2 to 4. So it goes up to 4. We could also do this in reverse. Just like we learned earlier, we can go -1. Whoops. And when we go to -1, it's the same thing because we have 0, 1, 2, 3, 4. This is the same thing as 2 to 4. It goes 2 to the last one. Also very common with arrays is you're going to want to sort them. So we still have our array up here that we randomly generated, and we might want to sort it, and we'll go and throw an axis back in there. Axis equals 1. If we run this, you can see from the axes that it sorts it, the 0.2 being the lowest value to the highest value by the row. We can also change this, of course, to axis 0 if you're sorting it by columns. So maybe your values are based on columns. And then, of course, you can do the whole array, and we can sort that. Don't usually do that, but I guess sometimes that might come up. And so you can see right here we have a nice sorted array. Something else, let's just go ahead and reprint our array so we can look at it again. Starting to get too many boxes up there. Something else you can do with an array is we can take and transpose it. This comes up more than you would think. When you transpose it, you'll see that the rows in the column are transposed. So where 0.79, 0.57, 0.064 is the column, now we've switched it and we have 0.79, 0.42 as the index. You can see this really more dramatic if we take a slice, and we'll just do a slice of the first couple, and then we'll just do all the other, the full rows. And if we run this, you can see how it comes up a little bit different. And we'll just do the same slice up here so you can see how those two look next to each other. There we go. There's our slice. Run. And so you can see the slice comes up and it has 1, 2, 3, 4, 5 columns. Now we have 1, 2, 3, 4, 5 rows and 3 columns versus 3 rows. And the original version, when they first started putting this together, was a function. So the original version was transpose, and this still works. You can still see it generates the same value as just a capital T. So many times we flip this data because we'll have an XY value or we'll have an image or something like that, and it's being read one way into the next process, and the next one needs it the opposite. So this actually happens a lot. You need to know how to transpose the data really quick. And we can go ahead, let's just take, here's our transpose. We'll just stick with the transpose on here. And instead of doing it this way, we might need to do something called flattening. Why would you flatten your data? If this is an array going into a neural network, you might want to send it in as one set of values instead of 2 rows. And you can see here is all the values as a single array. It just flattens it down into one array. So we covered our scientific means, transpose, median, some different variations on here. Some of the other things we want to do is what happens if we want to append to our array. So let's create a new array. I'm getting tired of looking at the same set of random numbers we generated earlier. So we'll go ahead and create a new array here, something a little simpler so it's easier to see what we're doing. And 4, 5, 6, 7, 8. That's good enough. We'll just do 4, 5, 6, 7, 8. And if we print this array, there it is, 4, 5, 6, 7, 8. And we might want to append something to the array. So we have our array, we need to extend it. You got to be very careful about appending things to your array. And there's a number of reasons for that. One is runtime. Because of the way the NumPy array is set up, a lot of times you build your data and then push it into the NumPy array instead of continually adding on to the array. And then it also it automatically generates a copy for protecting your data. So there's a lot of reasons to be careful about appending this way. But you can certainly do it. And we can just take our array, we're going to create a new array, array 1. And if we print array 1 and we append 8 to it, you'll see 4, 5, 6, 7, and then there's our 8 appended onto the end. And if you want to append something to an array, you'd probably also want to, whoops, array 1. Let's try that again. There we go. Now we have the 8 appended onto the end. So you can see 4, 5, 6, 7, 8, and then we appended another 8 on there. And if you're going to append something, you might want to go ahead and insert. Instead of appending, it might be you need to keep a certain order. And we can do the same thing. We can do our array. And we're going to append or insert at the beginning. And let's go ahead and insert 1, 2, 3. 1, 2, 3. And we go ahead and print our array 2. And we run it. And you can see 1, 2, 3 is inserted at the beginning. Insert's a lot more powerful in that you can put it anywhere in the array. We can move it to the 1 spot. And there we go. 1, 2, 3. We can do a -1. Just for fun, and you'll see it comes up 1, 2, 3, and we're counting backwards by 1. I imagine you can do a -0 and run this, and it turns out that -0 puts it back at the beginning because that's why it registers as 0, just takes a minus sign off. And just like we add numbers on, we might want to delete numbers. And so let's do an np.delete. Well, let's keep it a little bit, make it a little easy here to watch. We'll go ahead and create an array 3, and we'll do np delete. We were just working with array 2, and what we want to do is delete 0 space. So if you look at this, here's our array 2. Array 2 starts with 1, and when we delete the space on here and print that out, we deleted the 1 right out of there. And we can also do something like this, where we can do it as a slice. And we can do, let's do 1, 3. And if we run 1, 3, you'll see we've deleted the 1 space and the 3 space out, which deleted our 2 and 4. Now keep in mind when you're messing with adding lines and deleting lines, you have to be really careful because there's a time element involved as far as where the data is coming from, and it's really easy to delete the wrong data and corrupt what you're working on, or to insert stuff where you don't want it. So there's always a warning when we talk about manipulating NumPy arrays. And just like anything else we're doing, we'll create an array C, which equals, we'll just do our NumPy array that we just created, our NumPy array 3, and we can do copy. So you can make a copy of it. Maybe you want to protect your original data, or maybe you're making a mask, and so you copy the array, and then the new array make all these alterations and change it from values to 0 to 1 to mask over the first one. And of course, if we do array C, since it equals a copy of array 3, it's the same thing, 1, 3, 5, 6, 7, 8. And now we're getting into combine and split arrays. I end up doing a lot of this, and I don't know how many times I end up fiddling with this and having a mess. But you do it a lot. You know, you combine your arrays, you split them. You might need one set of data for one thing, another set of data for the other. So let's go ahead and create two arrays, array 1, array 2. And I want you to note, and the terminology we're going to look for is concatenate. And what that means is we're going to take, we'll call this array cat. I like array cat. There we go. Our array cat, our concatenated array, we're taking array 1 and 2, and it's very important to really pay attention to your axes and your counts. I can't merge two arrays that have, like, if their axes are messed up and I'm merging on axis 0, it's going to give me an error and I'll have to reshape them. So you got to make sure that whatever you're concatenating together works. And what that means, as you can see here, we have 1, 2, 3, 4, 1, 2, 3, 4, and then 5, 6, 7, 8, 5, 6, 7, 8 along the 0 axis. These each are 4 values. So it's a 2 by 4 value. And if we go ahead and switch this to 1, you can see how that flips it a little bit. So now we have 1, 2, 3, 4, 5, 6, 7, 8. It's interesting that we chose that one. If I did something like this, where this is now, there we go, and we concatenate it, run this, and it gives me an answer okay because I have 2 by 2, and I'm using axis 1. But if I switch this to axis 0, where now it's got 3 and 5, it gives me an error. So you got to be really careful on that to make sure that whatever axes you are putting together, that they match. So like I said, this one, oops, axis 1. Axis 1 has 2 entities, and since we're going on axis 1, or by row, you can see that it lets it merge it right onto the end there. And you could imagine this if this was a XY plot of value, or the X value going in and the predicted Y value coming out, and then you have another prediction and you want to combine them. This works really easy for that. And we'll go back, and let's just put this back to where we had it. Oops, I forgot how many changes I made. There we go. We'll just put it, whoops, I messed up on my concatenation order here. There we go. Okay, so you can see that we went through the different concatenation. Axes is really important when you're doing your concatenation values on here. And we'll switch this back to 1 just because I like the looks of that better. There we go. 2 rows. Now, there are other commands in here. So we can do cat v equals np v stack. This is nothing more than your concatenation, but instead we don't have to put the axes in there because v stands for vertical. And so if we print out cat v and we run this, you can see we get the 1, 2, 3, 4, 1, 2, 3, 4, and that would be the same as making this axis 0 for vertical stack. And if you're going to have a vertical stack, you can also have an H stack. So if we change this from V stack to, oops, here we go, H stack, and we'll just change this from cat to cat, and I run this, it's the same as doing axis 0. the process is identical in the background. This is like a legacy setup, your VStack and your HStack. Most people just use concatenate and then put the axes in there because it's much has a lot more clarity and is more commonly used nowadays. The last section in NumPy we're going to cover is kind of data exploration, and that'll make a little bit more sense in just a moment. Sometimes they call them set operations. But let's say we have an array, 1, 2, 3, 4, 5, 6, 3, whatever it is. You can see we generate a nice little array here. And what I want to go ahead and do is find the unique values in that array. So maybe I'm generating what they call a one-hot encoder. And so these values then all become, I need to know how long my bit array is going to be. So each word, each word is represented by a number, and then I want to know just how many of those words are in there. If we're doing word count, very popular thing to do. And you can see here when we do unique, we have 1, 2, 3, 4, 5, 6. Those are our unique values. Some of the things we can do with the unique values is we can also, instead of doing just unique, we can do uniques, our unique values, and counts of each unique value. And this is very similar to what we just did up here, where we're doing NP unique, but we're going to add a little bit more into there. And it's just part of the arguments in this. And we want to do return counts equals true. So instead of just returning the unique values, we want to know how many of those unique values are in each one. And we'll go ahead and print our uniques and print our counts. When we run that, you can see here we have our unique value 1, 2, 3, 4, 5, 6, just like we had before. And then there's two of the first of 2 1s, 2 2s, 2 3s, 2 4s, 1 5, 2 6s, and so on. And you can go through and actually look at that if you want to count them. But a quick way to find out your distribution of different values. So you might want to know how often the word the is used versus the word and, if each word is represented as a unique number. And along the set variables, we might want to know, let me just put a note up here. We're going to start looking at intersection, and we might want to also know differentiation and neither. So when we're, neither. So when we're looking at now is we want to know, hey, where do these two arrays intersect? And we have 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. We might want to know what is common between the two arrays. And so when we do that, we have NP intersect, and it's a 1D array, one-dimensional array. And then we need to go ahead and put array 1, array 2. And if we run this, we can see they intersect at 3, 4, 5. That's what they have common. And because we're going to go ahead and go through these and look at a couple different options, let's change this from intersect 1D. And we'll do the same thing. We'll go ahead and print this. So we might want to know the intersection where they have commonalities. Another unique word is union of 1D. So instead of intersect, we want to know all the values that are in both of them. So here's our union of 1D. When we run that, you can see we have 1, 2, 3, 4, 5, 6, 7. So it's all the different values in there. And the last, one of the last words, we have 2 more to go, is we want to know what the set difference is. And so that's where you'll see that, if you remember set, we talked about that being what they call these things. So the set difference of a 1D array, when we run that, you can see that 1 is only in one array and 2 is only in one array. And if we want to know what's in array 1 but not in array 2, we might want to know what is in array 1 but not 2 and what's in 2 but not 1. And this would be the set XOR 1D on here. So we have the 4 different options here where we can do an intersection. What do they both have in common? We can do a union. What are all the unique values in both arrays? We can see the difference, what's in array 1, but not array 2. So set diff, 1D. And then set XOR, what is not in 1, but is in 2, and what is not in 2, but in 1. So we dug a lot in NumPy because we were talking, there's a lot of different little mathematical things going on in NumPy. A lot of this can also be done in Pandas, although usually the heavy lifting is left for NumPy because that's what it's designed for. Let's go ahead and open up another Python 3 setup in here. And so we want to explore what happens when you want to display this. This is where it starts getting, in my opinion, a little fun because you're actually playing with it and you have something to show people. And we'll go ahead and rename this. We're going to call this Pandas and PyPlot. So Pandas PyPlot, just so I can remember for next time. And we want to go ahead and import the necessary libraries. We're going to import Pandas as PD. Now remember, this is a data frame, so we're talking rows and columns, and you'll see how Pandas works so nicely when you're actually showing data to people. And then we're going to have NumPy in the background. NumPy works with Pandas, so a lot of times you just import them by default. Seaborn sits on top of the Matplot library. So sometimes we use the Seaborn because it kind of extends. It's one of the 100 packages that extends the Matplot library. Probably the most common used because it has a lot of built-in functionality. Almost by default, I usually just put Seaborn in there in case I need it. And of course we have Matplot library as PyPlot, as PLT. And note we have as PD, as NP, as SNS, as PLT. Those are pretty standard. So when you're doing your imports, I would probably keep those just so other people can read your code and it makes sense to them. That's pretty much a standard nowadays. And then we have the strange line here. It says ampersand Matplot library inline. That is for Jupyter Notebook only. So if you're running this in a different package, it'll have a pop-up when it goes to display the Matplot library. You can, with the most current version of Jupyter, usually leave that out and it will still display it right on the page as we go. And we'll see what that looks like. And then we're going to go ahead and just do the Seaborn, the sns.set, and we're going to set the color codes equals true. Let them just keep the default ones so we don't have to think about it too much. And we of course have to run this. The reason we run this is because these values are all set. If we don't run this and I access one of these afterward, it'll crash. The cool thing about Jupyter Notebooks is if you forgot to import one of these, you forgot to install it, because you do have to install this under your Anaconda setup or whatever setup you're in, you can flip over to Anaconda and run your install for these. And then just come back and run it. You don't have to close anything out. And we'll go ahead and paste this one in here real quick where we have car equals pd.read_CSV. And then we have the actual path. This path, of course, will vary depending on what you are working with. So it's wherever you save the file at. And you can see here I have like my OneDrive documents, Simplilearn, Python, Data Analytics, using Python, / car CSV. It's quite a long file. When we open that up, what we get is we get a CSV file, and we have the make, the model, the year, the engine, fuel type, engine horsepower, cylinders, and so on. And this is just a comma separated file. So each row is like a row of data. Think of it as a spreadsheet. And then each one is a column of data on here. And as you can see right here, it has the make, model. So it has columns for a header on here. Now, your Pandas just does an excellent job of automatically pulling a lot of this in. So when you start seeing the Pandas on here, you realize that you are already like halfway done with getting your data in. I just love Pandas for that reason. NumPy also has it. You can load a CSV directly into NumPy, but we're working with Pandas, and this is where it really gets cool, is I can come down here and I can print, you remember our print statement, we can actually get rid of it, and we're just going to do car head because it's going to print that out. The head is going to print the top values of that data file we just ran in. And so you can see right here, it does a nice printout. It's all nice and in line because we're in Jupyter Notebook. I can scroll back and forth and look at the different data. And just like we expected, we have our column, and it brought the header right in. One thing to note is the index. It automatically created an index 0, 1, 2, 3, 4, and so on. And we're just looking at the head. So we got 0, 1, 2, 3, 4. You can change this. You might want to just look at the top two. We can run that. There's our top two BMWs. Another thing we can do is instead of head, we can do tail. And look at the last three values that are in that data file. And you can see right here, it numbered them all the way up to 11,913. Oh my goodness, they put a lot of data in this file. I didn't even look to see how big the file was. So you can really easily get through and view the different data in here. When you're talking about big data, you almost never just print out car. In fact, let's see what happens when we do. If we run this and we just run the car, it's huge. In fact, it's so big that the Pandas automatically truncates it and just does head plus tail, so you can see the two. So we really don't want to look at the whole thing. We'll go and go back to, let's stick with the head, displaying our data. There we go. So there's the head of our data. It gives us a quick look to see what's actually in there. I can zoom out if we want, so you can actually get a better view. Although we'll keep it zoomed in so you can see the code I'm working on. And then from the data standpoint, we of course want to look at data types. What's going on with our data? What does it look like? Now this, you show when you're talking to your shareholders, they like to see these nice, easy to read charts. They look like a spreadsheet. So it's a nice way of displaying pieces of the chart. When we talk about the data types, now we're getting into the data science side of it. What are we working with? Well, we have make model, we have an integer 64 for the year. Engine fuel type is an object. If we go up here, you can see that most of them are it's a set manual, rear wheel drive. So they might be very limited number of types in there. And so forth. And it's either going to be a float 64, an integer, or an object is the way it's going to read it on here. And the next thing you're going to know is like your columns. And since it loaded the columns automatically, we have here the make, the model, the year, the engine, the size, all the way up to the MSRP. And just out of something you'll see come up a lot is whenever you're in Pandas and you type in .values, it converts it from a Pandas list to a NumPy array. And that's true of any of these. So then you end up in a NumPy array. So you'll see a little switch in there in the way that the data is actually stored. And that's true of any of these. In this case, we want car.columns. You have a total list of your car columns. And like any good data scientist, we want to start looking at analytical summary of the data set. What's going on with our data? So we can start trying to piecemeal it together. So we can do car, describe, and then what we'll do include equals all. So a nice Panda command is to describe your data. If you're working with R, this should start looking familiar. And we come down here and you can see count. There's make, the model, the year, how many of each one, how many unique values of each one, the top value of each one, what's most common, the frequency, the mean. Clearly on some of these it's an object, so it really can't tell you what the average is. It'd just be the top one's the average, I guess. The year, what's the average year on there? All this stuff comes down here. Your standard deviation, your minimum value, your maximum value, what's in the lower quarter, 50% mark, where's that line at, and what's in the upper 75%, the top 25% going into the max. Now, this next part is just cool. This is what we always wanted computers to be back like in the 90s, instead of 5,000 lines of code to do this. Maybe not 5,000. All right, I built my own plot library back in 95, and the amount of code for doing a simple plot was, I don't know, probably about 100 lines of code. This is being done in one line of code. We have our car, which is our pandas. We generated that. It's our data frame. And we have .hist for histogram. That is the power of Seaborn. Now, it's still going to generate a NumPy graph, but Seaborn sits on top, and then we can do the figure size. This is just so it fits nicely on the paper on here. And we do something simple like this, and you can see here where it comes up, and it does say Matplotlib and does subplots and everything. But we're looking at a histogram of all the different pieces in our database. And we have our engine cylinders. That's always a good one because you can see like they have some that had a null on there, so they came out as 0. Maybe one of them had a 2-cylinder engine way back when. 4 is a common, 6 a little less common, and then you see the 8-cylinder, 12-cylinder engines. Boy, that's got to be a speedster or something. But you can see right here, it just breaks it down. So now you have how many cars with how many, whatever it is, cylinders, horsepower, and so on. And it does a nice job displaying it. You can see if you're working with your, you're going into your demo, it's really nice just to be able to type that in and boom, there it is. They can see it all the way across. And we might want to zero in and use like a box plot. And this time we'll go ahead and call the Seaborn, SNS, box plot. And we're going to go ahead and do vehicle size versus engine horsepower XY plot. And the data comes from the car. So if we run this, we end up with a nice box plot. You see our mid-size, compact, and large. You can see the variation. There's our outlier showing up there on the compact. That must be a high-end sports car. Large car might have a couple engines, and again we have all these outliers and then your deviation on them. Very powerful and quick way to zero in on one small piece of data and display it for people who need to have it reduced to something they can see and look at and understand. And that's our Seaborn box plot, or SNS.boxplot. And then if we're going to back out and we want a quick look at what they call pair plotting, we can run that, and you can see with the Seaborn it just does all the work for you. It takes it just a moment for it to pull the data in and compile it. And once it does, it creates a nice grid. And this grid, if you look at this one space here, which is, you might not be able to see the small number, it says engine horsepower. This is engine horsepower to the year it was built, and it's just flipped. So everything to the right of the middle diagonal is just the rotation of what's on the left. And as you expect, the engine horsepower gets bigger and bigger and bigger as time goes on. So the year it was built, the further up in the year, the more likely you are to have a heavy horsepower engine. And you can quickly look at trends with our pair plot coming up. And look how fast that was. It took it a moment to process, but right away I get a nice view of all these different information, which I can look at visually and kind of see how things group and look. Now, if I was doing a meeting, I probably wouldn't show all the data. One of the things I've learned over the years is people, myself included, love to show all our work. You know, we were taught in school, show all your work, prove what you know. The CEO doesn't want to see a huge grid of graphs, I guarantee it. So what we want to do is we want to go ahead and drop the stuff that might not be interested in. And I'm not really a car person. Our guy in the back is, obviously. So you have your engine fuel type. We're going to drop that. We're going to drop market category, vehicle style, popularity, number of doors, vehicle size. And we have the axes in here. If you remember from NumPy, we have to include that axes to make it clear what we're working on. That's also true with Pandas. And then we'll look at just what it looks like from the head. And you can see that we dropped out those categories, and now we have the make, model, year, and so forth. And we took out the engine fuel type, market category, etc. And this should look familiar to you now. When you start working with Pandas, I just love Pandas for this reason. Look how easy it is. It just displays it as a nice spreadsheet for you. You can just look at it and view it very easily. It's also the same kind of view you're going to get if you're working in Spark or PySpark, which is Python for Spark, across big data. This is the kind of thing that they come up with, and this is why Pandas is so powerful. And we may look at this and decide we don't like these columns. And so you can go in here and we can actually rename the columns. Simple command, car equals car, rename. Columns equals engine horsepower equals horsepower. This is just your standard Python dictionary. So it just maps them out. And instead of having like the lengthy, if here we had engine horsepower, we just want horsepower. We don't need to know it's the engine horsepower. Engine cylinders, we don't need to know that it's for the engine, because there's only one thing we're describing if we're talking about cars, and that's cylinders. And we'll go ahead and just run this. And again, here's our car head, and you can see how that changed. We have model year and horsepower versus model year, engine horsepower, engine cylinders, and just cylinders. Again, we want to keep reducing this so it's more and more readable. The more readable you get it, the better. And of course, we can also adjust the size a little bit so that when it prints out, instead of splitting it on 2 lines, we get like a single line. We can do that also. That's just your control mouse up or plus sign you use in Chrome. That's a Chrome command. And if you remember from NumPy, we had shape. Well, Pandas works the same way. We can look at the shape of the data. So we now have 11,914 rows and 10 columns. So you see some similarities because Pandas is built on NumPy. And questions that come up just like you did in NumPy, we might want to know duplicate rows. And so we can do car. And look at this switch here. We're doing a selection. This is a Pandas selection with the brackets. But we want to select it based on car.duplicated. So how many duplicates on there. So it's starting to look a little bit different as far as how we access some of the data on here. This can be a logical statement. And we get the number of duplicate rows. We have 989 rows by 10 columns again. And this is one of those troubleshooting things that we end up doing a lot, more than we really feel like we should. We might go ahead and do like a car count just to see how many rows we're dealing with. And then right after that, we might want to go ahead and say, hey, let's drop duplicates. So remember we did all the duplicates on there. So car equals car.drop duplicates. And then we can print the head again. We'll just do car head here. And you can see the data on there looks the same as before. And just note that we did car equals car.drop duplicates. There are commands in here where you can do, where it changes the actual value. And it works on some of them and not on others depending on what you're doing. But by default, it always returns a copy. So when we do this, we're reassigning it to car. And you can see it's the same header, but we want to go ahead and do count and see how the count changes. Let's go ahead and run this. And you can see here, instead of 11,914, we have 10,925. So we removed about 100 cars that were duplicated, just slightly under 100 there. And then as we're prepping our data, we might want to know car is null. So it's going to count the values of null, and then we want to sum that up. And when we do that, we do the car is null function.sum. We end up with HP, the horsepower is 69 have null values, and 30 have cylinders have null values. Now, if you don't put the sum at the end, it's just going to return a mask with the true false of is it null or is it not, by 0 and 1. So you're summing up the ones underneath each column. And this, of course, then you have to decide what you're going to do with the null values. There's a lot of different options. It might be that you need to put in the average or means. Maybe you want to put in the median value. There's a lot of different ways to fill it. Usually when you first start out with the data, a lot of them you just drop your null values. And you can see here car.drop NA, which is equal to all. And then we're going to go ahead and count it. And you can see that we've dropped almost another 100 values. So from 10,925 to 10,827, maybe 75 or so values. So we've cleaned this is really a big part of cleaning data. You need to know how to get rid of your null values, or at least count them and what to do with them. And of course, if we go back to counting our null values, we should now have null values. There we go. And you'll see there's 0 null values. I don't know how many times I've been running a model that doesn't take null values and it crashes, and I just sit there and look at it trying to get, why did that crash? It should have worked. It's because I forgot to remove the null values. So we've been jumping around a lot. We're going to go back to finding outliers, and let's go ahead and bring that back into our Seaborn. And if you remember, we did a box plot earlier. This time we're going to do a box plot just on the price. And you can see here our price value, and we have the deviation with the two thinner bars on each side of the main value. And then as we get up here, we have all these outliers. In fact, we have one way out here that's probably a really expensive high-end car is what we're looking at. If you were doing fraud analysis, you would be jumping on all over these outliers. Why are these deviation from the standard? What are these people doing? Again, this is probably, like I said, a really high-end expensive car out here. That's what we're looking at. And we can also look at the box plot for the horsepower. We'll put that in down here and run that. And you can see again, here's our horsepower, and it just jumps, and there's these really odd, huge muscle cars out here that are outliers. And we're going to jump into making this a little bit more, as you start displaying your data or your information to your shareholders. We're going to look at plotting a histogram for the number of cars per brand. And the first thing we want to go ahead and do is we have with our car, go back over here, here we go. We have our make value counts, largest plot, and we want to do a kind equals bar, figure size 10.5. And right off the bat, we jump up here and we see Chevrolet, it's going against, what was it? It's figure ratio, the value counts, and we want the largest value. So here's our value counts and compared to what the different cars are. Chevrolet puts out a lot of different kinds of cars. I didn't realize that they made that many cars or different types. And then for readability, let's go ahead and add a title, number of cars by make, number of cars, and make. If you had looked at this the first time, you would have been like, well, what the heck am I looking at? Well, we're looking at the number of cars by make. And then you can see here, now we're talking about the type of cars and the different ones are put out. Lotus, I guess, only had a few different kinds of cars over there. Very high-end cars. And then as doing data analytics and as a data scientist, one of the things I am most interested in is the relationship between the variables. So this is always a place to start. We want to know what's going on with our variables and how they connect with each other. So the first thing we're going to do is we're going to go ahead and set a figure size because we want to make sure it fits our graph. We'll just go ahead and set this one plot figure set to figure size 2010. If you never used the Matplotlib library, which is sitting behind Seaborn, whatever is in the PLT, this is what's loaded. It's like a canvas you're painting on. So the second you load that PyPlot as PLT, anything you do to that is affecting everything on it. And then we want to go ahead, since we're using Seaborn, we'll go ahead and create a variable C for relationships or correspondence, and car.corr. That's a correlation in Seaborn on top of Pandas. Again, one line and you get the whole correlation on there. And because we're working with Seaborn, let's put it into a nice heat map. If you're not familiar with heat maps, that means we're just using color as part of our setup. So we have a nice visual. And we can see here that the Seaborn connected to the Pandas prints out a nice chart. We'll talk a little bit about the color here in a second. It prints out a nice chart. This is a chart I look at. As a data scientist, these are the numbers I want to look at. And we'll just highlight one of them. Here's cylinders versus horsepower. The closer to 1, the higher the correlation. So 0.788. Pretty high correlation between the number of cylinders and how heavy the horsepower is. I'm betting if you looked at the year versus horsepower, we can just look at that one. Here's year and horsepower. 0.314, not as so much, but if you combine them, you don't actually add them. But if you combine them, you'll start to see an increase in horsepower per year and cylinders. You could probably get a correlation there. And just like 0.78 is a positive correlation, you might notice if we look at cylinders, or let's look at horsepower and mileage. So if we go here to horsepower to mileage, you get a nice negative. We'll do cylinders, that's a bigger number. With cylinders to the miles per gallon, it's a minus 0.6. So it's a negative correlation. The closer to -1, the more the negative correlation is. And then the chart you would actually show people is a nice heat map. This is all our colors, and it's just those numbers put into a heat map. The darker the color, the higher the correlation. You can see straight down the middle, obviously the year correlates directly with the year, horsepower with horsepower, and so on. That's why it's a 1. The closer to the 1, the higher the correlation between the two pieces of data. Now, this is a good introduction. Pandas goes way beyond this. Most of the functionality in NumPy, since Pandas sits on it, is also in Pandas, and then it even has additional features in it. And we use Seaborn pretty extensively sitting on top over our PyPlot. So keep in mind that our PyPlot has a ton of other features in it that we didn't even touch on in here. We couldn't, even if you had a sole course in it, there's just so many things hidden in there depending on what your domain you're working on. But you can see here, here's our Seaborn and here's our Matplot library. That's all our graphics that we did. And then the Seaborn works really nicely with the Pandas. We really like that.
Hi everyone. Python is one of the emerging programming languages. According to the most recent figures, Python is the most used coding language for about 80% of developers. The syntax of this high-level programming language is simple to understand. Python's large library system makes it a best choice for data science, machine learning, and artificial intelligence projects. And let us have a simple quiz question to brush upon our knowledge. And your question is, which keyword is used for function in Python language? And your options are, your first option is function, and second option is def, third is fun, or fourth is define. You can pause the video, give it a thought, and answer in the comment section below. And we will update the correct answer in the pinned comment. To do the financial analysis, first we'll go to our Python projects, and this is our data on which we would be doing the financial analysis, and I will provide you the link in the description box for this sheet also. So this sheet indicates that the genders male and female, how they invest, and what's their age, their investment in mutual funds, equity market, debentures, government bonds, and fixed deposits, and at how much duration, and how they invest daily, monthly, weekly. So we would be doing financial analysis on this sheet. So starting with, first we'll create a folder and name it as financial analysis. Financial analysis. Yeah. I was going to make a spelling mistake, but I didn't. So here we would open a Jupyter notebook in which we're going to proceed with our financial analysis. You could use any IDLE you want to use. I would be using the Jupyter notebook. For that, I will open the command prompt and write the command Jupyter notebook, and we'll get a Jupyter notebook open in the browser. Till then it's loading. We would move a CSV file into a folder only. Financial analysis. So it would be easy for us to do some tasks, like we can easily provide the link for the CSV file. Now moving to a Jupyter notebook, we have finance underscore data.csv in a folder. Now we'll create a new file and name it. We will name it as finance analysis. Now, starting with, the first thing we should do is import our libraries or import our modules. And first module we would be using would be NumPy, and we would be importing that. And to install that, you could just simply go in the folder, call the command prompt, and write pip install NumPy. You can easily find these commands to install any module on the web, or you can just see like what I would be installing, and you could see that the requirement is already satisfied, as I have already installed the NumPy and all other module that would be using in this tutorial. So you could just go to the command prompt and write the command, and the module would be installed for you. Now we would move back to a Jupyter notebook, and start importing our packages. And the first package, we have seen the command to install it, and now we will import it. That would be NumPy. We'll import NumPy and use the alias as np. And the second package we would be importing would be Pandas. For that, we'll write the command import Pandas, and we'll also use the alias here and we'll use as pd. And you can install the Pandas library by using the command pip install pandas, or you could just simply search on the web. You would get the commands there also. So I'll run this command. It's showing the asterisk mark. That's clear that our commands have been run successfully. So moving on, now you would see how many files are present in a folder in which we are making this Python notebook. So for that, we will first import the OS module, and you can simply install it by using the command that would be pip install OS, or for OS it would be pip install sys hyphen OS. So you could simply search on the web, or I would show you. I would open an incognito window for you and pip install OS Python. So you could see this is the official website for OS module. You could simply visit on that and you could simply copy the command that is OS -sys and just copy the command and paste on your command prompt. It would be installing your command easily, or you could also paste that command into your Jupyter notebook. It would do the same task for you. Now we want all the files that are present in a folder. So for that, we'll write for directory name, comma, underscore, comma, file names in os.work, and inside the curly braces, we would write the path for our folder, and we could simply copy the path of the folder from here. It's showing cmd.exe. Wait, first I will go back, and now I'll copy the path and we'll paste it here. And after the curly braces, I will just place a colon, and after that I'll write, I will run a loop that would be for file name. In file names, we would be printing os.path.join, and inside the brackets we will pass the directory name and the file name. Okay, and now we'll just click on run. You could see that it's showing 3 files, that is finance_data.csv and the ipynb file that has been created by us, that is financial analysis, and the checkpoints that the Jupyter notebook creates. And moving on, we would be installing some other modules, and first I will tell you about NumPy, that it's an open source and general purpose array processing package. It offers a multi-dimensional array object with outstanding speed as well as tools for interacting with these arrays. And about Pandas. So Pandas is an open source library designed primarily for working quickly and intuitively with relational or labeled data. It offers a range of data structures and procedures for working with time series and numerical data. And this library is built on top of the NumPy library. And it's quick and offers its users exceptional performance and productivity. And now we would be installing the Matplotlib. I have already installed, so I would be importing it. Matplotlib library and the Seaborn library. So for that, I would write the command, and before importing, I want to walk through with this. So os.walk function, it generates the file names in a directory tree by working the tree either top down or bottom up. For each directory in the tree rooted at the directory top, it yields a three tuple, that is directory path, directory name, and the file name. So moving on, now we'll install our modules, and that would be Seaborn and Matplotlib. So for Seaborn, you could easily write the command or you can search on the web how to install it. So for that, the command would be pip install Seaborn. So we would be importing it. Import Seaborn, and we would be using the allies here as SNS. And now we would be using the pyplot library, pyplot class of the matplotlib library. So for that, we would write the command matplotlib, and we would be using the pyplot and an alias for this as plt. So we would be using these two libraries also, and we have run the command and it has been executed successfully. It has turned the number to 3. Now if I tell you about Seaborn, so Seaborn is a library for making statistical graphics in Python, and it builds on top of Matplotlib and integrates closely with Pandas data structures. And Seaborn helps you explore and like it helps you understand your data. Its plotting functions operate on data frames and arrays containing whole data sets and internally perform the necessary semantic mapping and statistical aggregation to produce information product. Its dataset oriented declarative API lets you focus on what the different elements of your plots mean rather than on the details of how to draw them. You could easily draw them, so you don't have to think like how to draw them. You could just simply import this library and start your functioning. Now moving on, we have Seaborn library also. So it's a Python data visualization library that is based on Matplotlib. It provides a high level interface for drawing attractive and informative statistical graphics. As now we have imported all the libraries, we can start with our project. And first thing we would be doing is we would set the default style, that is, we would set the style function that would be used for plot styling. And for that, we would be using the alias of Seaborn and use the function set underscore style and will mark as dark grid. We'll run this. So it has been executed successfully. As you can see that the number has turned out to be 4. So now we would read the file, that is a CSV file, and to read that we would declare a variable and name it as df, and we'll use the pandas library to read that and write the command pd.read underscore csv, and inside the circular braces we would write the path for the file. So we'll copy the path and in the inverted commas we will paste the path, and at last we could just write the file name, and the file name was finance underscore data dot csv. So here spelling is finance. I have written the wrong spelling for the file, but it's okay. We'll use the same. Finance underscore data dot csv. So now we'll just run this, and you could see that our file has been loaded. So as you can see, our file is already loaded, and the reads underscore csv function, it takes a path to a csv file and reads the data into a pandas data frame object. Now we would be using the df dot head function and run it. So what does this function do? So it is used to get the first n rows. That is, this function returns the first n rows for the object based on position. It is useful for quickly testing if your object has the right type of data in it. So it has shown us that is the 5 rows and mostly all the columns. And it's showing you that 5 rows cross 24 columns. There are 24 columns here, and it has shown you all the columns. Now we will drop some columns from the sheet, and to drop them we will write a command that would be df, in which we have stored the sheet, the df variable, and inside that we will write command that is drop, and inside the circular braces we would write the columns we want to drop, and the name would be we will drop columns that would be mutual funds, equity market, debentures, government bonds, fixed deposits, ppf, gold. So we will drop these columns, and to drop them we will write the name of the columns in the square braces. So first we will write the name of the mutual funds. It's capital now. Mutual funds, mutual underscore funds, sorry, mutual underscore funds. And the next we want to drop is equity market. For that we will write equity market, that is in inverted commas, and M was capital for equity market. Now debentures, and that too in inverted commas. Uh, the next was government bonds, fixed deposits, ppf, and gold. Okay, so in inverted commas we'll write government bonds, and then it was ppf, and there was fixed deposits, and there was gold also. Okay, now we have listed all the columns that we want to drop, and now we would set the axis equal to 1, that is from the same axis x is equal to 1, these all the columns would be identified and they would be dropped, and they would be stored in the df variable. So for that we'll write like we'll set the axis, and axis would be equal to 1, and we'll set in place that would be equal to true. Okay, so now we'll run this command. Okay, main equal to okay, so we will use c is equal to 1 and place equal to 0. Just find out. We'll just restart it. Now after restarting we'll try to run it. Okay, so there is of equal to in cells and 900 x is equal to 1 and in place is equal to 2. Okay, circular bracket would be closed here. Yeah, Our command has been executed successfully. As you can see in the square braces, we have a number 8. That means the command has been successfully executed, and we have dropped these columns. And now moving on, we'll use the replace function. That would be the pandas replace function, and we will replace all the empty columns with nan, that is not a number value. And for that, we'll write a command df, that is df equal to df dot replace, and inside we will write command dollar, and this would be enclosed in the inverted commas and a comma afterwards, and np dot nan, what we want, and then set regex, that is equal to true. And now if we run this, it has been executed successfully. And the replace function, it replaces all the occurrence of matched pattern in the string, and a regular expression, that is regex, we have used here, that is equal to true. It's a sequence of characters that define a search pattern. And to filter rows is pandas, like to filter rows in pandas by regex, we can use the string dot match method. Now moving on, here we would start with the plotting, and we'll use the seaborn, and we'll draw our first plot. That would be the bar plot only, and for that we will use count plot function, count plot, and we'll set the x parameter as gender. You could see in the sheet gender, we are setting it as x, and the next thing we would set would be data. That is, we would take the data from the variable df in which we have stored the file, that is the CSV file, and line width for the plot, and we'll set it as 3, and then we'll set the palette, and that would be equal to set 2, and then we'll set the edge color, and that would be black. And after that we would use the function that would be plt.show, and we'll run the command. As you can see that we have set the x parameter as gender and count, so it's showing how many males and females are investing at, like what are the numbers in this sheet, how many males are investing and how many females are investing. So moving on, and first if we see in here, so we have used the count plot function, that is the method used to show the counts of observation in each categorical bin using bars. And we have set the x, that is the parameter that takes names of variables in data or vector data, or optional inputs, that is used for plotting long form data. And we have used palette, that takes the value of the palette, and it is mostly used to show the hue variable. And what is hue here? Hue is the parameter that specifies the column name. And we have set the data is equal to df, that is the parameter that defines the data frame that we would like to take for the representation. For instance, data can be an array. And moving on, we will draw another plot using the seaborn only and the count plot function. So sns dot count plot, and inside we will pass x parameter equal to age, and then we'll pass the data that would be equal to df, and set the palette that would be equal to set 3, and then we'll set line width that is equal to 2, and then we'll set the edge color of the plot, that is the bar graph. we'll set the edge color, that would be black. And now we'll run this. You could see that it has X label as age and Y label as count. That is at how many age men and women both combined are investing. At the age of 21, two women or men, like two people, we would say. We won't make it consideration as gender here. So we are just counting how many people are investing at which age. So moving on, now we'll move to another plot and draw something related to age only. And you could also use plt.show to just get your output. If you write here plt.show, it will give you the same output. And here now it's not showing the x-axis and y-axis. You could easily see here what it's defining. Now moving on, now we'll draw a figure and using the Matplotlib, and here we will be using two plots, and I would like you would understand with this only. First we will draw it and then I will explain what I want to show you. So first we will use the Matplotlib alias, that would be plt dot figure, and inside we are passing fig size, that would be equal to 18,6, and after that I will be using the subplot, that is we would be drawing two plots here, and for one subplot plt dot subplot, inside we would pass the parameters for this subplot. The first we have defined the figure size, the whole figure, and inside there would be two plots, and inside those plots what would be the size for one plot, so that would be defined by plt dot subplot. And now sns dot count plot, we would draw count plot here, and inside we'll pass the x parameter, that is equal to df, and inside we'll pass the column, that would be gender, and here we'll set the hue, that is equal to df, and inside the bracket, that is a square bracket, we'll write the investment avenues, that who all are investing. And was there underscore? Yeah, there was underscore, investment underscore avenues. And now we have set the hue here, and now we'll set the palette. To set the palette, we would set the palette as summer, and after setting the palette we would set the line width for the plot, that is the bar, and we would set as 3, and after that we would set the edge color, and edge color would be equal to white, and now we will give the title to this subplot, only this subplot, and for that we would write a command plt dot title, and inside this title we would write investment venue, and after that we would draw another subplot, that would be plt dot subplot, and for that we will define the parameters, that would be 1 comma 2 comma 1 2, and we'll use sns dot count plot, and inside we would set the x parameter, that would be df, and inside the square brackets we would define gender, and set the hue, that would be equal to df, and inside hue we would write for the stock market. Stock market. And now we'll set the palette, and we'll set the palette as hot only. Now after setting the palette, we would set the line width. Line width of the plot, that would be equal to 3, and after line width we would set edge color, that would be equal to white, and after that we would set the title for it, plt dot title, and inside title we would set it as stock market, and use the function plt dot show to show both the graphs. Now we'll run this command, and we got an error, that is stock underscore market. So we'll check. Okay, marktet. So we have the column name here, marktet. So we'll use the same and run it. So you could see there are two subplots and they are inside the figure, that is of the value 18,6. And here we have gender and count, that is investment avenue, who all are investing. And here we have who all are investing in the stock market, and according to the gender, like in females, how many are investing in stock market, they are indicated by red color, and those who are not investing, they are indicated by yellow color, and same with the men. And if you see, we have used a fig size here, that is a tuple of the width and height of the figure in inches, and we have set the inches here. And subplot, that means groups of axes that can exist in a single matplotlib figure. And subplots function is the mat that is stored in the matplotlib library and helps in creating multiple layouts of subplots, and it provides control over all the individual plots that are created, and we have created that. Now moving on, we will create another count plot using the cbone, and for that we would write the command sns.countplot, and inside we would pass the x parameter, that would be equal to df, and inside we would pass factor, check with a sheet, that is the factor. So we will pass this and set the palette for it and line width and edge color, and we'll draw the count plot. So the factor is how the people are investing, like they are looking for returns or they are investing for locking period so that their investment could be stored for longer period of time, or they are risking their investment to have some more interest or more returns. So for that we would be drawing the count plot, and we have set x equal to factor, and now we'll set the palette. So we'll set the palette equal to cool warm, and now we'll set line width, that would be equal to 2, and now we'll set the edge color, that would be equal to black, and we'll use the function plt.show. So just run this command, and you could see that we have a subplot here, not subplot but a plot, and that is a bar plot, and you could see how many people adjust for returns, that is 25, and who have lock-in period and who are risking their investment. You could see the count here using this count plot. And now moving on, we will use Matplotlib and have another figure, and here we will be having our plot that is for purpose, like which purpose, for which purpose the people are investing. If you could see the purpose here, that is for wealth, savings, for which purpose they are investing, wealth creation or just savings for future or returns. So we'll create a plot here, and for that we'll use Matplotlib, and we'll write the command plt.figure, and inside we would set the figure size, that would be equal to 16,8, and after that we would set sns dot point plot, that is we would be pointing the plots, and set the x parameter as purpose and y parameter, that would be equal to age, and now we'll set the data, that is equal to df, and now we'll have the line style. As you'll see, this would be a different plot here, and we'll set the line style with this style, and now we'll set cap size, that would be equal to 3, not 3, that would be 0.3, and after setting the cap size we'll set the color, and we'll set the color as blue. Now we'll write the command plt.show and run the command for you guys. So we got an error, that is figure size, and that would be equal to, not equal to, equal to. Now we'll run this again, and we got point plot, got an line style. Okay, we have line style, and that would be line styles. Yeah, we got our output. That is, you can see this graph. This is for just having the purpose and seeing the age. What would be the median age for what purpose? Like, who are investing for wealth creation, what is the median age? You can see here, for saying for future purpose you can see the median age, and for returns purpose you can have the median age. We have used the line styles here, that is line style is used for each of the hue levels, that is for each of the column levels, and we've set the cap size, that is the width of the caps on error bars, and that we have set as 0.3. Now moving on, we will create another plot, and that would be our last plot only. So for that we would be having the Matplotlib library only, and would set figure, and here we would be having two subplots. So first we will define the figure size, that would be fig size, and that is equal to 18,6, and now we would use the subplot function plt.subplot, and we would define the parameters for subplot, and now we'll use cbone sns dot use the count plot function to have a plot, and here we'll pass hue, that would be setting as gender, and now we'll set the x parameter, that will set as duration, for what duration people are, no, but we'll have the gender here. So for what duration each gender is investing. Now we'll set the palette and duration, that would be in inverted commas. Now we'll set the palette, that is palette equal to where it is. You could see the design of the plot, that it would be where it is. And after that we'd set the line width, and that would be equal to 2. After setting the line width, we would set the edge color, that would be equal to black. And after that we would set the title of this subplot, and would set the title as duration. And now we would have another subplot. For that subplot, we would write the command plt dot subplot, and inside we would pass the parameters for this subplot, that is 1 comma 2 comma 2. And now we would use the count plot, and inside the count plot we would pass hue, and that is equal to df, and inside we would pass gender. For that we would pass the x parameter, that is investment monitor. We could see in the sheet, that is investment monitor. Oh, sorry, like how these genders are investing. They are investing monthly, weekly, or daily. So we would see that in this subplot, and we are passing the investment monitor as the x parameter. So we'll pass it investment underscore monitor, and after the x variable we'll set the palette, and the palette would set as seismic. You could see what seismic is when you will see the plot, and you could use after if you liked, else you could use another palette. And now we'll set the line width, and that would be equal to 2. After that we would set the edge color, that would be black for this. And now we'll give the title to this subplot, and we will give the title by using the command plt.title, and in the inverted commas we'll write investment monitoring. And after that we'll write the command plt.show and run the command, and we got an error here, that is investment monitor. So we'll see invest underscore monitor, it's not investment monitor. So title is okay, yeah, invest underscore monitor. Run it, and you can see both the subplots have been displayed here. The first is duration, and it's against the count here, and you could see the genders, that is female and male, that is how males and females are investing their investment for what time period, that is 1 to 3 duration, for more than 5 years, for 3 to 5 years, and for less than 1 year. And if you see investment monitoring, that how genders are investing their amount, that is how they are investing monthly, what numbers, like you can see that the blue colors indicate female invest monthly, and that would be in the range 10.0 to 12.5, that is around 11. And if you see men, they are above 17.5. And same as weekly and daily. And with that, we have come to the end of this session. The session was interesting and informative. If you liked it, please let us know in the comment section below. And also do subscribe for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.